Hello again, it's Kalen Langley in ECE 275 Digital Design. We're going to be learning how to display the BCD equivalent of a 4-bit binary number on a 7-segment display. Here you can see the 7-segment display and all the different LED positions. So you have A, B, C, D, E, F, and G. And we're going to be displaying the result of the binary equivalent on that LED. The first step in this was to draw the truth table and K-map for all the different combinations. So here, in order to show the 0, you would need all these LEDs on except for G, as you saw on the assignment. So all these combinations would be on except here and so forth up until you get to 9. And then the only one that is off there is E. So you'd have 9, and then any combination after that are invalid. Now the K-maps for the minimized expression for each segment are seen here. So you have segment A, segment B, segment C, and segment D. And we have E, F, and G. So I'll go ahead and launch Model Sim now. All right, I have already simulated the wave here. We built the test bench, I added all the objects to the wave window, and then we started the simulation. But we'll step it through together now. For 0, all the segments should be on except for G. You can see that here. G is off, the rest are on. And then for 1, the only segments that should be on are Bravo and Charlie. B and C are on, the rest are off. Now going to 2, should have C off and F off according to our truth table that I had up earlier. C is off and F is off as well. So that's lining out just fine. Now we're going to move to segment or number 3. 3, the only LEDs that should be off are E and F. E and F are off, the rest are on. Going to 4. On 4, you should have A, Delta, and Echo that are off. So you have A, D, and E are off, the rest are on. That checks out. Moving on to 5. 5, you have B and E should be off, the rest are on. B and E, that looks good. Now to 6. 6, the only one that should be off is Bravo. Yep, that looks good. Now moving to 7. You should have A, B, and C, the rest are off. A, B, and C, D through G are off. Now moving on to 8. They should all be on, as you can see here. They're all on. Now to 9. And the only one that should be off is Echo. And it's off as you can see there. Now, in this Model Sim code, we excluded the invalid inputs. So everything from 10 to 15 just had turn off. And then I had extended my simulation time a little bit longer just so I could see it pick back up, and we can check it again to make sure it's still running correctly. So for all combinations, or sorry, for all inputs of 0, the only one LED that should be off is G, as you can see here. Now, the other portion of this assignment was to build this in Walkly as well. I've posted a link here. I'll just go ahead and open it up now. All right, here is our 7-segment display here. The task was set this as the anode with the VCC as the input to the common. And here's our 8-position dip switch inputs. And then I built the logic gates all, let's undo that, all according to the K maps on the PDFs that I showed you earlier. So go ahead and simulate this and see if it works, just like we saw on the Model Sim simulation. So with all LEDs off, we have 1. So I'm just going to step it up, going from 0000 to 0001 and 0010 and so forth, all the way up to 9. So let's turn that extra LED off. It's just bugging me. Okay. We have 1. Turn that one off. And then 2, 3. Turn those 2 off. 4, 5, 6, 7. Turn those 3 off. 8 when you have A1, B, C, D, 0. And then the last one is 9 for all the valid inputs. There you go. And we can work it back down the other direction. Go to 4, we need to turn those 2 off, that one on. Then we turn that one off and these 2 for 3. Turn this one off for 2. And then we switch it for 1 and then turn it off for 0. All right, so that concludes it for the walkway simulation. Thank you for your time.